Okay, in this video, we're going to learn about qualitative analysis. And before we do that, we have to understand the differences between quantitative analysis and qualitative analysis. So quantitative analysis tells us how much of a given ion is present in a solution, right? We're looking for a number, a quantity, right? So that is quantitative analysis. When we're learning about qualitative analysis, we're simply identifying if a particular substance is present in a sample or not, right? So qualitative analysis can tell you what ions are present in a solution. We do this using things like color, right? So what color does it turn, or what precipitates are formed? So in qualitative analysis, you are describing whether or not an ion is present, whereas in quantitative analysis, you're trying to figure out how much of that particular ion is present. There are three methods for qualitative analysis, and we're going to learn about all three in this video, starting with flame tests. So many metal ions produce a very unique color when they are heated in a flame, right? And because of this, we can use that particular unique color that's produced in a flame to identify what is present in an unknown sample. So if I have an unknown sample and I expose it to a flame and it turns a lavender color, I can just simply go to my list of different cations and what color they turn when they're exposed to a flame to try and figure out what is in that unknown substance. So I mentioned that it turned a lavender color. So based off of this chart, potassium is present in that unknown sample, right? So using that, I can identify what ions are present in different unknown substances. So this is another visual that shows the exact same thing, how different metals can form different colors when they're exposed to a flame. The second type of qualitative analysis involves colors of ions in different solutions. So if I take a look on the right side here, I've got two different sections, cations and anions. And when all of these ions are in aqueous solutions, they cause those solutions to turn a very unique color. So for example, permanganate turns a purple color, and iron 3, if it's in an aqueous solution, turns a pale yellow. So using these colors, we can use or we can identify different ions that are present in a solution, right? So we can use this as one of our methods of qualitative analysis. And lastly, we are going to use precipitation reactions. Now, this takes us back to when we learned about reactions, we learned about precipitates that could be formed in double displacement reactions, right? And in order for us to identify that, we used what we call a solubility chart. And the solubility chart is going to be used by us to try and confirm whether or not certain ions are present in our solution or in our unknown sample. So let's take a look at the solubility guidelines. I've got the solubility guidelines on the left side and the chart on the right side. It doesn't matter what you use, whatever one is easier for you. So if I'm looking at an unknown substance or an unknown solution, I can use this solubility chart to confirm the presence of certain ions. So here's a situation. If I have a mixture that has a bunch of different ions in it, if I introduce fluoride to that particular mixture, so if I introduce fluoride in the form of a compound, so I add NaF to this mixture. So say I have this mixture with a bunch of different unknown ions mixed in there. Okay, and I'm going to introduce fluoride in the form of, NaF, right? So when NaF is added into it, if this particular mixture forms a precipitate, then I know that one of these four different cations might be present in that particular mixture, right? Because I know that these, when magnesium fluoride is formed, it has a low solubility. So it's not just going to mix into the ions, it's going to form a solid. Now, I don't know if it's going to be magnesium fluoride, calcium fluoride, barium fluoride, or lead fluoride, but I have to do additional tests to confirm that. But initially, I can try and narrow down what ions are present using these solubility rules so that I can confirm that there are certain ions present or not. Okay, so let's take a look at an example. So there are 3 unlabeled bottles containing white solid compounds. They are found in a chemical storeroom, and they are suspected to form or they are suspected to contain NaCl, MgCl2, and KCl. Okay, how can we use our qualitative tests to confirm which one contains which of these compounds, right? So let's go in order. We'll try and do all 3 of these tests to see how we can confirm which of these compounds are found in which bottles. Let's start with the flame test. And in our flame test, I'm going to take each of these samples and I'm going to expose it to a flame, and I'm going to see what color comes out of there. So NaCl, when it's exposed to a flame, what color is it going to produce? Let's take a look at our chart. If sodium is involved in a compound and it's exposed to a flame, it's going to form a yellow-orange color. So whenever this, or whichever one of these 3 produces a yellow-orange flame, I know that that one is going to be NaCl. MgCl2, let's take a look on this chart. I don't see it on here, so when I expose it to a flame, it's likely going to form no color, right? There's going to be no difference between the color of the flame and the color that this turns it. Okay, and lastly, KCl. If I take a look at my chart here, potassium turns a lavender color. So whichever one turns lavender, I know is going to be KCl. So using the flame test, I can in fact confirm which is going to be which of these compounds. Okay, let's take a look at how we would use the second qualitative analysis to try and figure out this particular problem. So I've got NaCl, MgCl2, KCl. Let's take a look at our chart to see if any of these form colors in aqueous solutions. And I don't see sodium, magnesium, or potassium anywhere on this chart, which tells me that I cannot confirm using this particular test which one is in which bottle, right? So I can use the flame test, but I can't use this particular test. And that's okay, because you might have a situation where you can use this test, but you can't use the flame test, right? So these are supposed to be meant to be used together to help you narrow down what ions are present in different solutions or substances. And lastly, let's see if we can use our precipitation reactions to confirm which compound is in which bottle. So if I have NaCl, MgCl2, as well as KCl, how can I precipitate these out? So what will precipitate Na, what will precipitate Mg, what will precipitate K? That's the question that I'm asking myself. So let's take a look at our solubility guidelines to see how we can figure this out. So I'm first going to take a look to see if anything will precipitate sodium out. And the answer is that nothing will, right? So if I take a look at the first guideline here, the hydrogen ion, ammonium ion, or all group 1 ions form soluble compounds with nearly all anions. So it doesn't matter what I add to this particular compound, I'm not going to be able to precipitate NaCl out, right? And KCl, potassium, also is an alkali metal that falls into that category, and I cannot precipitate that out. But let's see if we can precipitate magnesium chloride out. So, magnesium out. So if I add fluoride in a form of a compound to that bottle, and magnesium is present, I will have a precipitate that's formed, right? So I've got fluoride reacting and forming a compound with magnesium, that's going to have a low solubility. So if I expose or add, let's say, NaF, and whenever I'm adding a reactant to one of these reactions, I always want to add it, if it's an anion, I want to add it with an alkali metal because I know that that itself is not going to precipitate, right? So Na, whatever alkali metals, whatever they're bonded to, they're going to be soluble, right? So that's not going to be the precipitate. So I want something that's not going to get in the way. So when I have this, when I add these together, I'm going to produce MgF2, which is a solid, plus I'm going to produce NaCl, which is aqueous, right? So what this tells me, so if I add NaF to this, plus NaF, I'm going to have no reaction, right? And if I add KCl to NaF, I'm also going to have no reaction. So the only one that's going to form a precipitate, that's going to help me narrow down that that particular bottle contains MgCl2. And I'm not super worried that I can't identify NaCl or KCl because I've got our flame test here, right? So I should know from our flame test that this is going to form a yellow-orange color, and that this, again, with a flame test, will produce a lavender color. So using all of our tests, I can confirm what compounds are in what bottles. And usually in these precipitation reactions, I'm adding, remember, double displacement, I'm adding it with a particular compound. I'm not just adding in F2, right? I'm adding in NaF. So I want this to be a reaction that precipitates out this particular compound so I can confirm that this is going to have MgCl2, right? And it works for all kinds of different compounds. If you want to precipitate out a very specific ion, you have to do it in a very unique way. Okay, I'm going to leave you with this particular question for you to try and do, and I'll leave the answer on D2L for you to check, right? It'll be a really good practice for you to see if you can identify which test tube is going to contain strontium, silver, or calcium.